Okay, welcome back, everybody. This is the Virtual Residency 2026 workshop. It's Monday, June 22nd, and this is our third session of the day. This is Cyberinfrastructure User Support, and our speaker is Farouk Garamani. And Farouk, take it away.
Thank you, Henry. I'm Farouk Yaramani, Vice President for Research, Innovation, and Sponsored Programs at New Jersey Edge. New Jersey Edge is a regional research and education network based in New Jersey. A little bit about me. My educational background is I have a bachelor's in mathematics from Pennsylvania State University with a minor in biology. And then I also have a master's in computer science from Villanova University, an MBA from DePaul University, and a doctorate in higher education management at University of Pennsylvania. About my career, I've spent half of it in industry and half of it in higher education. And most of my work has been in high performance computing and at the intersection of leveraging advanced and emerging technologies to accelerate research, innovation, and workforce development. And there are many synergies in the work that I do, as well as the engagements that I have in communities such as virtual residency, the CARC community, the Campus Champions, and the Ecosystem for Research Networking are some of the examples. At Edge here, we have a CC Star Regional Networking Award, which brings together 7 institutions from one community college, 3 small liberal arts colleges, and several other non-R1s, and then one R1 in a resource sharing environment, Science DMZ, Sonar networking and monitoring tools, as well as all of the institutions, partner institutions, have in common membership as part of the project for 2 years. We also, as a part of the Campus Champion leadership team, I'm the PI on the Campus Champion Eager Nair Award, where the focus of that is workforce development for around AI for the Campus Champions, as well as a mentoring program. And we have a workshop coming up at Perk. So today's workshop is CI user support from access to effective use, research productivity, and communications. The central message is that CI user support is the bridge between sophisticated infrastructure and actual research outcomes. Researchers don't experience cyber infrastructure necessarily through architecture diagrams. They experience it through getting an account, moving data, submitting jobs, installing software, debugging errors, and understanding what can be possible. So this presentation draws from over a decade of virtual residency and ACI rep user support materials. And it basically provides for information about what users expect, how to classify support needs, how support teams operate, and how to handle common HPC problems, and how outreach and training can reduce barriers before they become actual support tickets. We define CI broadly to include computing systems, storage, instruments, repositories, visualization environments, high-speed networks, software, and people. And it's really important to note that people are not peripheral. People are part of the infrastructure. the support staff, the facilitators, the research software engineers, system administrators, network engineers, data specialists, the librarians, and the research office staff all contribute to whether if infrastructure is actually useful. And our goal is not just to peak performance, our goal is research productivity and discoveries that would otherwise be difficult or impossible. So I think I skipped one. It's important to explain why CI value is in practical terms. So researchers turn to CI when science takes too long on desktops, when jobs run out of memory, when data movement becomes a barrier, when licensed or specialized software is needed, when visualization or databases are required, or when visualization or databases are required, or when the workflow needs to scale across many cases. The value of CI is not always maximum floating point operations. The value is reducing the mean time to science, to helping researchers to get from question to results faster. We need to define what cyber infrastructure is. It includes computing systems. It includes storage instruments. Oops, I already went through this. Sorry. So it's important to understand how CI differs from conventional IT. This comparison helps us to support our colleagues who come from enterprise IT. Conventional IT focuses on standardized services such as identity, email, desktops, finance, payroll, ERP systems, and baseline security. CI is different because it's performance oriented, can be discipline specific, and often irregular. Users can compile custom codes, they can rely on unique versions of libraries, move terabytes of data, run workflows that stress the scheduler, or need configurations that conflict with the defaults. CI also relies heavily on conventional IT. So it's very important to make sure that we have good relationships across teams. And this is really an essential aspect of CI user support. It's important to understand the CI value. Researchers turn to CI when science takes too long on desktops, when jobs run out of memory, when data movement becomes a barrier, when licensed or specialized software is needed, and when visualization databases are required, or when a workflow needs to scale across many cases. The value of CI is not always maximum floating point operations. The value is reducing the mean time to science, helping researchers get from question to result faster, more reliably, and with less friction. It's important to manage stakeholder expectations. And based on the audience, the expectations can be a little bit different. Institutional leaders often want value, faculty recruitment, grant competitiveness, prestige. publications, graduations, and reasonable cost models. Faculty and PIs want reliable resources. They want their students or their collaborators supported without excessive friction. Hands-on users want short queues. They want clear answers. They want help with software and data and support that's matched to their level of knowledge. The same support request may have all three expectations behind it. For example, a student asks about a queue delay, the PI is worried about a manuscript script deadline, and the institution wants evidence that the system is used fairly. So expectation management is very, very important. In this slide, demonstrating that support spans the entire user journey, not just the moment of crisis. A researcher may first learn that CI exists through outreach, then attends a workshop, requests an account, submits a first job, moves data, installs software, scales the workflow, resolves some errors, and eventually can use the results in a paper or a proposal. Each stage has different failure points and different support opportunities. And good support teams design pathways across the whole journey so that users don't have to rediscover the process every step of the way. As far as user categories, there are three broad user categories that we can define. There's the novice user, there's the intermediate user, and the advanced user. And these are not necessarily labels to impose on people. They're practical guides for being able to match the support needed in response to the requests. A novice may need reassurance, exact commands. An intermediate user may need deeper explanations and data. An advanced user may need peer level collaboration and flexibility. The language that's used in tickets, the kind of follow-up questions users ask, and the history with the system will all help to identify the right level. When uncertain, you can assume novice, but it's important not to make the assumption visible or patronizing. I think, it's very important in the communications to listen, understand what the needs are, be empathetic, and present yourself as a partner in helping them to gain the support that they need. Typically, novice users may have limited command line experience, limited Linux knowledge, little understanding of clusters, schedulers, modules, or parallelism. They may be highly capable researchers, but unfamiliar with this environment. Their tickets may involve login procedures, SSH keys, two-factor authentication, finding software, locating documentation, moving data, or writing the first job script. Some questions may sound simple, but reveal where the gaps are. The support goal is to build confidence and to make the user feel safe in asking simple questions. And if once we're successful in doing that, then it will help the users to become more self-sufficient. Um, For novice users, support needs to be explicit, replicable, and encouraging. Providing regular orientations, some beginner documentations, some job script templates, links to help locations, suggested search terms, and exact command sequences are helpful for novice users. It's important to avoid answers that assume hidden knowledge. Um, Explain acronyms if you're using acronyms. Um, and also, for example, we don't just simply say, check your quota, show the command, show what the output means, and explain one or two next actions. The tone of our communications really matter, whether if it's in verbal or written. Um, Many times, novice users are already worried that they're asking basic questions, and our support response needs to make it easier for the novice users to ask that next question. For intermediate users, they usually have prior experience with clusters or command line tools. They often create job scripts, manage virtual environments, and troubleshoot some problems themselves. They may run the largest portion of the compute activity and may be the first to notice some system problems. Their requests often involve complex software installations, job arrays, parameter sweeps, performance issues, special versions, migration problems, or requests for more control. They may have strong opinions because they have used other systems. These users can become local experts for their labs, so investing in them has multiplier effects. Our intermediate users can usually tell when an answer is speculative. That doesn't mean that support needs to know everything immediately. It means support should be transparent, such as, I don't know yet, but here's how I will investigate. Using evidence, logs, scheduler data, documentation, some vendor guidance, and clear explanations. Some advanced workshops and domain-specific examples helps the intermediate users. Some one-on-one consultations are often efficient because their workflows are more specific. Capturing exceptional use cases in documentation so that difficult support interaction becomes a reusable resource is very helpful. Turning exceptional cases into better documentation. Advanced users may be hands-on faculty, research staff, postdocs, or advanced students. They may use multiple clusters, develop parallel applications, build complex workflows, use accelerators, request special configurations, or find bugs in hardware, libraries, or third-party applications. They may bypass the ticket system because their problems are complex or because they have an established relationship with someone on the technical team. They often need peer level engagement. These users can become powerful advocates for CI programs if they feel respected and supported. For advanced users, applying an intermediate playbook, but also raise the level of collaboration. You can meet regularly when appropriate, learn about the research, ask about deadlines and aspirations, and involve them in pilots, hardware evaluations, grant proposals, or advisory groups. A lot of times these users get really excited about new projects and being involved and as an active partner with CI user support. It's important to not to ever say something is impossible too quickly. Um, Separate what's technically impossible from what is supported, um, but may be risky or not yet prioritized. Making small exceptions when they don't impact others, but also documenting them and watching for potential areas of challenge and issues. And also, peer level respect doesn't mean policy-free support. The policies are important, and making sure that your users are aware of the policies. So what we'd really like is to have some interaction and participation from everyone in this session. We have three examples, sample requests here, and it would be interesting for you to provide, you know, what level of user do you identify with request A, with request B, and request C? And what would be your first follow-up question? So request A is, I copied the example script, but it says command was not found. What do I do? How would you answer this question? And what category would you put this particular request, and how would you answer it? Anyone? Um, okay, some inputs coming in. So the point of this is not necessarily to prove a single correct category, but to practice reading signals. For the first example, the user likely needs novice support with exact commands. The second may be intermediate because it involves performance and scheduler resource understanding. And the third may be advanced because it involves containerized GPU software and version constraints. What would be a follow-up question that you would ask first? Can jump, if you'd like to jump in and provide your answer verbally, that would be great. Please unmute.
Is your latest question about request B?
Yes.
Yeah. Maybe just providing their Slurm script just so that you can kind of see how they've set it up. Their S batch, yeah.
Great. How about request C? What would a follow-up question be?
What operating system is the person using also could be a factor here.
Mhm. That's great. Any other follow-up questions?
I will say for number C, my typed answer said cite policy first, where it, likely gives you 2 weeks or something, unless it's an emergency. Probably that's a little bit harsh. I might actually ask, is this an emergency or can it wait two
And what
weeks?
constitutes an emergency?
Well, exactly. What exactly is it an emergency on their part? So then I
Like,
can react accordingly without causing
mm,
them panic.
yeah, like a sense, an urgency based on a specific deadline. Sounds good. There's some really good discussion. In reviewing the support operating model, a strong model can include intake through tickets, consultation, a knowledge infrastructure through documentation and templates, a team cadence for handoffs and prioritization, and evidence through metrics and reports, and escalation routes to sysadmins, vendors, national communities, or local partners. Uh, Recommendation is daily or weekly huddles, which can help support staff coordinate. Office hours can reduce email back and forths, and ticket systems can create history. Closed tickets alone are not the measure of success. The real measure is whether the users can make progress. So it's important to somehow be able to track that. Ticket systems prevent requests from getting lost, create support history, and help teams see patterns and develop processes based on those patterns, processes, policies. But they should not become the wall between users and help. Some problems require live consultation or screen share because a long email thread becomes frustrating for everyone. A good recommended practice is to acknowledge quickly, request the most useful details, and convert this to a meeting when the problem is ambiguous or urgent. The tickets also reveal where documentation is missing. If the same question appears repeatedly, it's important to treat it as a system design or documentation opportunity. So be able to follow up with specific processes and policies. Some common HPC tickets or problems are variations on a small number of families, problem families. Access problems include accounts, SSH keys, two-factor authentication, or on demand. Storage problems include quotas, permissions, data movement. Software problems include modules, compilers, containers, some versions and dependencies. Scheduler problems include queues, job scripts, arrays, some limits. Performance problems can involve memory, I/O, GPUs, scaling, or efficient workflows. Workflow problems can include reproducibility, migration issues, multi-step pipelines. Some mapping requests to families helps teams to build documentation, templates, as well as some triage questions. So understanding the patterns that repeat helps to streamline specific types of scenarios and questions as they come in. This particular workflow is a simple workflow, but it's very powerful. It's important to clarify first what changed, what exact command was run, what error appeared, and what outcome was expected. So clarification. Second is can support reproduce the problem? Is it replicatable? Third is to classify is this a system issue, software issue, a workflow issue, policy issue, or user practice issue? And then the fourth is to actually try to resolve it or to escalate it. Try to fix, teach the user, document the answer, or bring in system admins, vendors, or communities that can help with addressing the issue. And then the fifth is closing the loop, explaining what happened and how the user can avoid or recognize it next time. The significance of this type of workflow is that it's helpful. It protects both the user as well as the support team. Access tickets are common, especially when it has to do with novice users. The support response should avoid making the user feel like it's too simple an issue. Starting by acknowledging the issue and asking for the minimum needed details such as username, login method, exact error, system name, and whether the user is on campus, VPN, or external network. Checking account status, identifying the group membership, two-factor enrollment, SSH key configuration, and maintenance notices. If the problem is resolved, support should explain the cause in plain language if it's recurring pattern to improve the onboarding documentation or account activation messages. So it's an opportunity to improve some of the processes. And many times for these novice users, especially access issues are the first impression of the CI program. So having this go smoothly is very important for users to come back for help if they need it. And storage issues often involve quotas, permissions, where data should live, and how to move large files safely. A user may say the system is broken when the real issue is full home directory or writing large temporary files to the wrong file system. When explaining the difference between home, project, scratch, archive, and transfer locations will be helpful. Providing commands to inspect usage, identifying large files, and moving data. When possible, to offer a recommended pattern. For example, where to keep the code, where to stage input, where jobs should write temporary output, and how to move final results. Software support can be one of the hardest areas because user workflows combine scientific packages, compilers, MPI stacks, Python or R environments, containers, and version constraints. The first step is to identify the exact software version, input the environment and the error. Ask whether the user has a working example somewhere. Uh, Use modules, containers, environment files, and documented recipes when possible. And it's important to avoid building one-off solutions that you're not able to maintain. If a software request is complex or broadly useful, consider documenting it as a supported pattern or a training topic. So sustainability is really an important aspect of the user support. Some issues related to the scheduler issues are where technical support policy collide. Users may complain that someone is hogging the nodes, that a job has waited too long, or that the scheduler is unfair. It's important to start with the facts. So, what is the queue status? What are the requested resources, the job limits, the fair share, account allocation, the reservations, and policy. And to make sure that you explain the wait time depends on requested wall time, the nodes, the memory, the GPUs, the partitions, the priority, and the system load. Helping users to request resources accurately is an important part of this type of support. Sometimes the best support is helping a user to ask for less or so the job starts sooner and uses the system more efficiently. So really listening to what the need is, understanding it, and then breaking it into chunks. Um, Performance questions are very rarely just make this faster. They require understanding the code, the data, the architecture, and goal. So understanding is the job CPU bound, memory bound, IO bound, GPU bound, or waiting on communication? Is the workload serial or embarrassingly parallel or tightly coupled? Is the user comparing the cluster to a laptop without accounting for I/O or queue time? Support teams do not necessarily have to solve every performance problem, but they can help identify where the bottlenecks are and support profiling tools improve job requests, and connect users to advanced help or vendor resources. Policies and maintaining are very important aspects of user support. They are not necessarily just rules. They are tools for trust and fairness. It's important to publish policies in easy to find places, explain the rationale, and keep them updated. Making policies conservative enough to protect the system and the community, but leaving room for documented exceptions when necessary. Maintenance communications is another trust building practice. It's important to set regular windows, announce them in advance, and define primary and secondary goals, preparing fallback plans, testing before reopening, and providing a summary after the work. When policies, system configurations, scheduler behavior, and communications align, then there's less conflict. Conflict decreases. Conflict is inevitable in CI support because resources are typically limited. Deadlines are usually real, and users may be under pressure. The recurring guidance from the source materials is clear, so do not take frustration personally. It's important not to get personal, not to retaliate. Also, if there are maybe times when it may be considered harassment, to report that if necessary and use empathy, policy, and data as you're interacting with the community. It's important to acknowledge both the technical problem as well as the impact on the user. And frequent communication matters even before a solution exists so that the user knows where things are at all times. Sometimes the best first message might be, I see the problem, I understand the deadline, and I have started investigating, just so people know what to expect and when to expect it. And there will always be users that will want exceptions. And as we said, we have policies, but there is always some room and flexibility for exceptions when possible. So here's another example, a set of examples, and how would we address these? The user says, before responding, someone is hogging the node is the comment. Before responding, it's important to be able to ask, is there a scheduler issue? Is there misuse? Is the user under deadline pressure? Is the policy clear? Using evidence is important, looking at queue data, job size, wall time, allocation, partition limits, and documented policy. It's important to explain what's happening, some of the practical options. And also making sure that relationships are being maintained across groups. The user might be right, partially right, or simply frustrated. It's important to avoid blaming users, um, using data to explain what's happening and suggesting changes to the user's job requests if it's helpful. Also, escalating policy questions through governance. The goal is fairness, transparency, and not necessarily winning an argument. Researchers and CI professionals often use the same words differently. A CI professional may hear SSD and think solid state drive. A speech language researcher may mean speech sound disorder. A facilitator may recommend singularity or obtainer and assume container, while a physicist may hear a concept from relativity. Translation is not necessarily dumbing things down, it's reducing the ambiguity so people can solve the same problem together. Using fewer acronyms, defining terms, using analogies, paraphrasing the request, and asking the user to confirm your understanding all helps to bridge the communication gaps. Teaching is a core support function for CI support, and it appears throughout the support process. And there are many forms. There's documentation, there's workshops, guest lecture series, office hours, one-on-one consultations, and even ticket replies. The purpose is not simply to deliver content, it's to enable the researcher to do their work independently and to be self-sufficient. Good teaching requires motivation, um, and effectiveness as well as improvement as far as um, providing feedback, getting peer review. And it's important to understand why is the user motivated, what motivates the user, what format fits that particular need. Is the session achieving the goal if it's a one-on-one session or if it's a guest lecture or a workshop? Also, what feedback or peer review can potentially improve? The best teaching reduces future support load while increasing the user's confidence and research productivity. Matching the training to the user level is also very important. Introductory training covers getting started, command line basics, on-demand scheduler basics, data transfer, modules, and first job scripts, while intermediate training can cover debugging software environments, containers, workflows, profiling job arrays, and domain examples. Advanced training can cover GPUs, scaling performance tuning, complex software, reproducibility, data repositories, and specifics around some pilot projects. The training pathway needs to be visible. Users should be able to self-assess and find the next appropriate resource without having to ask support where to start. Documentation is a support multiplier. It is persistent, it's accessible, it's adaptable, and referenceable. But documentation will only work if it matches the current system and what the user needs. Good documentation starts with user questions, not internal architecture, prioritizes getting started guides, annotated examples, error message explanations, some templates, data movement recipes, software environment patterns, and policy pages. If multiple tickets ask the same question, it's create and improve a page, record a short video, and link it in future responses. Documentation is not separate from support. It is support. So it's important to have your documentation be a living document where it's evolving based on the changes and evolving needs. Outreach can answer some questions, basic questions. How do users know the CI team exists? How do they know whether CI could help their research? How do they know where to get help or where training is available? There are listservs, there's newsletters, there's department presentations, digital signage, websites, social media, research office partnerships, grant announcements, and word of mouth can all help. Outreach is not only advertising, it's community awareness and customer identification. Understanding who who the researchers are, what their needs are, is very important to being able to identify the types of user support that's needed. So proactive outreach helps to identify the needs of the community. Building goodwill with current users because researchers talk to each other and trusted recommendation from a colleague can be more effective than a broadcast email. So those building relationships across campus and the best advertisement is when your users are raising your praises and especially as it relates to new faculty uh, on campus. Okay, a strong professional is not necessarily someone who knows every answer. It's someone who knows where to find help, how to ask questions, and how to bring the right expertise to the user. So CI user support does not mean that you're doing the support on your own. There are many other resources that are available that can help you to accomplish your role, the goals of your role. National and regional communities can help with training, mentoring, allocation pathways, AI resources, research computing practices, and some vendor-specific problems. In my introduction, I mentioned some of the communities, such as CARC, Campus Champions, Virtual Residency. These are all communities where we learn from and we're able to bounce things off of that we're working on and basically to gain some best practices to bring back to our own local communities. So it's really important, and also local campus partners are important as well. Uh, the libraries, the research offices, IT security, data management teams, departments, faculty champions. For CI user support, actually for any kind of individual, it's important to build your network. Um, Building the network is a core professional skill in CI user support. So the whether if it's with the research community, with central IT, with regional and national communities, as well as with other partner organizations on campus, the bigger your network, then the easier your job will be because you'll have all those that expertise to rely upon as needed. Metrics can help stakeholders to understand the scale and efficiency of support. Some examples include tickets, time to resolution, active users, allocation requests, workshop attendance, documentation usage, storage, compute utilization, publications, grants, consultations, and there are many other ways of being able to justify existence by using the metrics. The numbers alone rarely capture the human value. So the stories are the ones that show how support helped a first generation, for example, a first generation student get started, or a new graduate student become productive, or helped recruit a faculty member, or helped a team meet a deadline. It's the recommendation is to use both the metrics as well as the stories um, to be able to demonstrate why the work that you're doing as in CI user support matters. And metrics should improve support. Um, Closed tickets are useful, but they're not the whole story, as we mentioned earlier. It's important to track a balanced set, volume, responsiveness, recurring issue categories, training attendance, documentation usage, consultation topics, user growth, allocation growth, and qualitative outcomes. For leadership, connect the metrics to institutional goals such as faculty recruitment, grants, publications, students, student success, compliance, and shared infrastructure value. You can use metrics to identify bottlenecks. For example, repeated storage tickets may indicate a documentation gap, onboarding gap, or a quota policy problem. User support is CI user support is also important as it relates to proposal development. This is another area of value, and there's when you look at the requirements based on the proposal, there's a progression. At the very basic level, support teams answer questions about hardware, software, storage, networks, or facilities. At the next level, they provide facilities documentation, some budget input, letters of support, and then at a deeper level, they help to write or revise CI portions of the proposal. At the most strategic level, CI user support may initiate or co-develop proposals for new resources, training, or community programs. This work positions CI user support as a research partner and helps infrastructure investments connect directly to funding science, to funded science. And this is just a practical checklist. A mature support culture has clear entry points, good documentation, regular training, office hours, escalation paths, respectful communication norms, policy transparency, maintenance communication, metrics, stories, and community connections. None of these has to be perfect. The question is whether the support team is intentionally improving the environment based on what you have heard so far. I would encourage you to identify one weak link in your local support chain and one realistic change you could make in the next quarter. And please feel free to share in the chat or unmute to share verbally. Everybody's pretty quiet. Well, hopefully you can think about it and take it back to your campuses. Some key takeaways in summary. Support, I hope you have taken away from this session that support is both technical and relational. Second, user categories are helpful for choosing a support strategy, but each user is an individual, and it's important to listen and understand what the needs are. Third, policies, documentation, tickets, metrics, and escalation paths turn ad hoc support into a reliable service. And fourth, teaching and outreach reduces friction before tickets happen. So being proactive is really an important aspect of what we do. Fifth, community matters. No support team should work alone. And finally, the measure of success is not just closed tickets. The measure is whether researchers can do more science faster and with greater confidence. In converting what the takeaways from the session into action, I'd like for each of you to focus on one of the four areas listed here: better onboarding, better troubleshooting, better training, or better value communication, and name one concrete change you could implement locally. Um, And you can enter it in the chat, or if you'd like to unmute, you're welcome to unmute and share verbally. So I want to close with the fact that small support improvements compound over time and really provide attribution to the source materials that are over 10 years. And also the recurring themes across all of the materials is that expectations, user categorization, policies, conflict management, teaching, outreach, troubleshooting, metrics, and stories are all part of the recurring themes as far as user support. So, thank you so much, and would like to open it up to discussion and specifically answering that last question. What would you take away from this session and implement in your specific institutions? Cody?
Hi, thanks. Great presentation. You have so many great points, and I think the interesting part is sort of providing a standardized view or standardized practices. There's such a desire for bespoke approaches or the culture of individual labs being so different that they want their own approach. And some of that is self-protective or about the identity of the researchers. I mean, if you really get to sort of um the social aspects of it, they want to do things their own way. And IT in particular then somehow become even more bespoke within those areas. How how could we promote a more standardized approach um w in a way that's aligned with culture or all the different cultures?
Hmm. Yeah, so that's the challenge is that there are so many different cultures, but I think one of the areas that there's an effort through the CARC organization where they're professionalizing the RCD profession, and within that process, develop basically sharing of best practices and sharing of those user stories to identify patterns and then developing some level of standards. However, having flexibility because each user is different, each environment is different. Um, but your point is very important in that we do need we do need to have some standards, and what body is going to create those standards. And I believe professionalization of the RCT profession will help in moving towards that, and the communities that we belong to in being able to come together and share our stories will all be very helpful. So I'm not sure if I have an answer to your question, but I think that, these types of communities, virtual residency, or campus champions, CARC, raise the visibility of the importance of having those types of standards.
Yes, thank you.
Yeah, and there are different um, different phases. So, for example, Daniel has listed onboarding, um, the opportunities that are there for common issues, documenting those issues, and then being able to share across institutions, across campus with other researchers that from different domains to be able to identify how certain issues have been resolved.
Is there any tooling like on a on the product side or on other private industry sides? There's sort of a customer relationship management approach where this is like that's used to manage all the different aspects of, you know, customer. And I we don't use the word customer, and faculty don't like the word customer,
Mhm.
but something it there's nothing like, is there anything like that on the research side? I mean, that would be an indication of the maturity is that we have tools that would help.
I'm not aware of it. However, having sessions like this is raising the visibility that these types of tools are necessary. And so we've we've progressed to a point where it's identified that CI user support is important, and then making sure that the CI users have the necessary tools to support the community. And so formalizing that is something I'm not necessarily aware of. However, I know that uh, it's something that needs to be addressed. And I could try to find out if there's anything. I mean, I know of the CARC effort. I know that EDUCAUSE has had an effort for quite some time as well. However, having the specific tools for CI user support, I'm not aware of. In general, I mean, there is the CARC research computing and data capabilities model, which helps in plan for institutional planning purposes. Um, However, what you're asking for is really more of a support tool for CI users. And is anyone else aware of any kind of tool on this call?
It's also tools within teams. Just to offer an example, we were helping um, a faculty member who arrived from a different university, and they had to bring over their entire lab, extensive equipment, and they were being supported by a research concierge, uh, capital programs project manager, and several other project managers. And it it seemed the de facto tool was sort of just Microsoft Office, like in terms of managing all the complexity across all those groups. And that faculty researcher was a very capable person, so just managed it mostly themselves, but it was rather chaotic. IT wasn't coordinating with the research concierge well, the research concierge essentially just sort of left all IT things to IT, but then IT couldn't quite figure out how to support all the needs. So it's really interesting like how much effort went into that. And there was no we acknowledged that did not have a common tool set.
Yeah, yeah. And it's important to also acknowledge that it's not a one size fits all, where a tool might work for central IT, would also work for CI support. I think. Any other comments? And I believe we're coming up on time. I want to thank everyone for joining the session.
All right, and thank you, Faru. This has been terrific. Let me go ahead and shut down the recording.
Thank you.